Now that we've uploaded our sequences and taken a general look at their quality, we'll go to the next major DNA subway stop, which is the edit sequences stop. Here we'll clean up and assemble our sequences for downstream analyses. So this will involve trimming the sequences and pairing our forward and reverse sequences to build what's called a consensus sequence. Let's take a look at sequence trimmer in action. Before we actually do the trimming, I just want to show you a couple of the sequences and what they look like before they've been trimmed, and remind you, here's Trey's reverse read, and it's got a bunch of ends on the front and back end of the sequence that are going to need to be trimmed off. Let's look at his forward read, same deal, a bunch of ends on the 5' end and a bunch of ends on the 3' end. Okay, so remember what those looked like before. Now let's go to Edit, Trim Sequences. And all you got to do is hit the magic blue button that says Auto Trim All, and it will trim all of your sequences for you. So now it's trimming off those ends on the front and back end of each sequence. And if we go back and look at the sequences, we're going to just look at Trey's. Now those ends are gone off the front and back end. For the reverse read, same deal for the forward read. And it'd be the same if you looked at any of the other sequences. They've all had the ends trimmed off. Just to look at this one more time, you can see a before and after comparison of Trey's reverse read. In the before, in the red boxes, you can see the end tails on the 5' and 3' end, and after trimming, you can see that those ends are now gone. So let's go ahead and pair our sequences up. Under Edit, you'll hit Pair Sequences. It'll be tempting to hit Auto Pair All, but that won't work. Instead, what you're going to do is figure out which is the forward and reverse read for each sequence. Mark the reverse read by clicking over the R until it turns red. Then select the little toggles or the check marks to the left to pair up the two that you want to pair, and then give them a label. So here for Mike, we're clicking the reverse read, checking those two boxes, putting in Mike as the sample name, and then hitting Save Pair. And you can see that each of these is now getting paired up for the next step. Before we use the consensus editor in DNA Subway, I just want to orient you to what it's going to look like. This will be the output in DNA Subway. The top strand here in consensus editor is your forward read. The next strand down is the reverse read, and they've been aligned. And then the bottom sequence with the colored letters is your consensus sequence. A few important things to note in the consensus editor screen. Lower quality base calls are indicated by lowercase letters, like the lowercase g pointed to by the red arrow here. And recall that a lower quality base call is one with a Phred score less than 20. In other words, it is less than 99% accurate. You also might see highlighted regions. These indicate mismatches, or places where the forward and reverse reads don't match one another. For example, you can see those two highlighted G's are G's in the forward read, but A's in the reverse read. Typically when this happens, the software automatically selects the nucleotide with the highest confidence in that position, or the highest Phred score in that position. And if you were to click on any of those individual letters in the consensus sequence, you can actually look at the electropherograms and compare the quality of the calls at those positions to see which letter was selected. So I'm going to do a very quick demo of how to trim and edit your consensus sequences. But before we do that, I want to remind folks that for the purposes of this course, we typically recommend that you only trim tails of your consensus sequence if greater than 400 base pairs remain after trimming them. If not, you probably shouldn't trim, or at least ask your instructor. So let's take a look at what I mean by that and how to edit your consensus sequences in this video. So here you see Jessica's sequence. You can click on a letter and it will left trim. You can click on a letter in the consensus sequence at the other end and it will right trim. And you can see that there's still 588 base pairs remaining. So let's look at Mike's or Luis's sequence. Once again, what we're doing here is we're trimming off the regions where there's no overlap, because we can't necessarily trust the accuracy of the sequences in those regions because they're not being double checked by both a forward and reverse pair. So where there's not overlap, we're trimming off those ends. And if it's remaining greater than 400 base pairs in length, we're keeping the consensus sequence. So here, let's look at Mike's. We're trimming off that tail and this tail where there's just a single reed. And when we're done trimming, the trim consensus length is only 194 base pairs long. So I'm clearing those trims and just saving the untrimmed sequence for further downstream analyses. Whereas if we go to Trey's sample, here we can trim off that end, we can trim off this tail end where there's no overlap in the consensus sequence, and at the end, the trim consensus length is still 663 base pairs long, so it's okay to save that trim. So I've done that for each of these sequences. Once you're done, you can go back to Select, and you've now got consensus sequences under your current files, and you can view and copy those individual consensus sequences by clicking on View Sequence and then Copy to Clipboard. So if you need to paste this into your lab notebook, your final consensus sequence, you can copy it to your clipboard and paste it into your lab notebook that way. As a quick recap of the edit sequences stop and sequence assembly with the goal of making the longest, most accurate sequence, there's been 4 main steps. Number 1, you've taken a general look at your DNA sequences to see their sort of quality. Then you've trimmed the sequences to get rid of the bad calls on either end. Then you've paired up the sequences, and then finally built and trimmed a consensus sequence to have your most accurate DNA sequence for your downstream analyses.